it's actually a very important part of it. We have a more traditional, it has to do with the difference between motor learning and motor performance. How about motor performance? There we go. Purposeful. Yeah, we have it. It's in your notes. It's what you're doing now. I can observe you writing. So that is a writing performance. I can observe you throwing. That's a performance. Learning is a permanent change in performance. Now that's really, I mean, those are definitions. But this model says how do you get from performance to learning? So it's not just definitions, which are nice to have, and we have you do all this vocabulary, but it's application. That's what this is. How do you get from just doing performances to getting a permanent change in performance that we can label learning? And you got to go through all that model. You got to go through the model. Yep. And as I said last year, the biggest part of the model is the thing in red, the brain. And that's where, Kevin, it gets from short-term memory to long-term memory. Because where you learn things is in the brain. And where you keep them is in memory. And for those of you that haven't heard this, muscles have no memory. Muscles have no memory. What's actually remembered is the brain remembers which muscles to use. And the brain sends signals to those muscles, and the muscles contract. But the memory of it, the muscles are down here. The memory of what muscles you use in the brain. But muscle memory is a nice, we're really into sound bites. Muscle memory is a really nice sound bite. But what we do is, it's up here. And what we want to do, this is where processing occurs. It says information processing. I'm giving a big picture here. I want you to not try to figure out what does each box mean. I want you to think big picture. Information processing is we use it. We use information. Okay. And we use that information to create a motor program. And that motor program is the brain sending signals to the muscles. Okay. We do information processing. It's all done in short-term memory. Unfortunately, short-term memory is like RAM memory on your computers. Turn it off, it's gone. Long-term memory is where we get to store things. That's the hard drive on your computers. If you store the right things, what happens? You can pull it back out and do it again. What if you store the wrong things? You can still pull it back out and do the wrong thing, and that's my golf swing.
How about open learning? What is open learning? What would you classify that as? Long-term memory?
Well, you tell me, what does it mean to you?
Well, with your model, I would put it with long-term memory.
Okay, so overlearning would mean you were doing it so much that whatever is in there, it's in there to the point is that it's...
Like yes.
Yeah. It's so well placed in long-term memory that over very long periods of time, we can still retrieve it. Okay. Now, so our goal is to get people to do those two arrows as many times as possible. Because one arrow says put it in, the other arrow says take it out. The more we do that, the more you get to overlearning. Overlearning. You do it, I mean, have you ever heard this thing? It's just an expert has done things 10,000 times. So what does 10,000 represent? How many times I did that? That's what 10,000 means. It doesn't actually mean 10,000 performances, because there's a very specific requirement for those two arrows, is that you have to be deliberate in what you do. If I go to the golf course and I swing my golf club and all I do is swing the club, I can swing it 100 times and only did one deliberate practice. Because deliberate practice means you're paying attention. You are attending to what you are doing. So I could do 100 golf swings, and if I'm just thinking about something else while I'm out there, whatever that may be, the next multiple choice question I want to write, whatever it may be, for those of you that have had my multiple choice assessment questions, I'm not attending to my golf swing. What am I attending to? My cognitive thing. I could be attending to, it's hot out here. I'm not learning. So the 10,000, I don't think they leave it out in those studies. I think once again, we're going for the soundbite. Somebody wrote a research study that said that experts have done things 10,000 times. I think somewhere embedded in that article says 10,000 was deliberate, not just 10,000 attempts.
And the unfortunate thing about that is, it sounds like experts have done something 10,000 times. If they do it 10,000 times incorrectly, they're an expert at doing things incorrectly.
Absolutely.
They've made that progress.
And we would still call it motor learning.
Right.
That's the only thing. We would still call it a permanent change. Permanent incorrect. But still, it still meets our definition of motor learning. Like I said, I'm still trying to undo the 10,000 trials of my golf swing that were bad. And how hard do you think it is to undo? I'm not saying I did 10,000 trials. It's hard.
Because kids' names, students' names, they let you say it wrong. And then at the end of the year, you're not saying my name.
I mean, one of the funny things I started to understand about this is that the more you do something wrong, the more, when we say overlearning, I think overlearning is that we make such a strong connection to that material that it's hard to break. So what if it's to the wrong material? Gravity! Those of you that have had biomechanics with me, gravity! Do we have a strong connection to what the definition of gravity is?
Negative.
Everybody has something, except the one I want you to know, which is that gravity is the attraction between two objects. No number to it, no units to it, just the attraction. It came from Einstein, not from me. I have this feeling that Einstein was not exactly the easiest person to get along with and to share that information. So it's not Newton that did it. Newton had a different idea, but Einstein came along and said it was wrong. And it was accepted he was wrong, but no one actually knows that he said it. It's an attraction. It's an attraction. But that's not what we're doing right now. I'm using it as an example. All of us have what we believe is our definition of gravity. And you've had that for years and years and years. In fact, it's so well learned that you probably don't even think about what you say when I ask you what's gravity. You just, that's the answer. 9.81. It's a force.